All right, so multiplication of fractions. So like when we went with addition before and subtraction, to be able to pull this off, we have to identify two things. What does multiplication mean, and then what is a fraction? So just a reminder, fraction is an equal part of a whole. And then as far as multiplication, what that's going to mean is last time we decided that the area model is a good one to go with. And alternative to the area model can be groups of if you look at it just right. So we'll start off by looking at area, and then we'll switch over to groups of and see how it goes. So if multiplication is finding an area, area is generally considered to be base times height. We often call it length times width, right? But I always have a hard time when I'm drawing deciding which one should be the length and which one should be the width. And usually if we go with base times height, base should be the bottom and the height should be coming up perpendicular to that, okay? So considering multiplication as an area, we need to see what a whole is with area. Well, a whole would be a region that measures 1 by 1. Right? So this, as far as our key is concerned, is one whole. And then we can ask questions about it. For example, we could say, well, okay, what's an area of 2/3 by, say, 1/2? So in this case, I want my base to be 2/3, so I'd have to break the base into pieces. So I'm going to knock this into thirds there, and then I need to select 2 of those thirds for my base. The height needs to be broken into 2 pieces because I have halves, right? Equal parts of a whole. And so I need to pick one of those halves. It could be the top half, could be the bottom half, it doesn't matter. That's up to you. But maybe I'm going to pick those there. Now, when we do that, we're essentially cutting this whole square cake. And so continue those divisions through in both directions. I need the region of this that is 1/2 by 1/2. And so I'm pretty sure that that's this region right here. So now I got to figure out what the answer is. And remember, a fraction's equal parts of a whole, right? So I have to figure out, in this case, this figure right here is what part of the whole, if a whole is this 1 by 1 figure. Well, one way to look at it is I have 2 equal small pieces out of how many equal pieces for the whole thing? And we can count and see that there's 6. And somebody else might look at it a little bit different. Somebody else might look at this and say, well, you're looking for pieces that are this big. Well, there's one right above you right there. And this one's oriented different, but there's one right there on the side. So somebody else might look at that picture and say, I see the answer as being 1 piece out of 3 in a whole, if I look at the blue highlights. So do we have 2 possible correct answers based on this picture? Yeah, we definitely have 2 possible answers. Before you do multiplication, you'll have done lots of building and reducing fractions. So in the past, students will have taken things like 1/3 and turned it into 2/6, and they'll have taken 2/6 and turned it back into 1/3. And so that connection will start to be remade there about reducing or building fractions. So let's try another one of those. Let's try, how about 3/4 by 1/3. So draw a square unit And then let's break it up into our base and our height. So my base has to be broken into thirds, or no, excuse me, fourths. And I need to consider 3 of those. And it doesn't matter which 3 I pick. It helps to pick them next to each other. So maybe this is my 3/4 over here. And my height needs to be broken into thirds, maybe there and there, to the best of our artistic ability. And so let's say I'm going to pick that as my 1/3 for the height. And so it looks like that is my whole. That is my product. So my product seems to have in it 3 pieces, and a whole looks like it is 4 by 3 or 12 pieces altogether, so 3/12. Now sometimes these can be reduced and sometimes they can't. If you think you can reduce it, you can always reduce it by the picture too. Like we can look at this and say, oh, well, I know that 3 goes into the top and 3 goes into the bottom, so I'm going to get 1/4. So somehow the picture should show us 1/4 also. So any suggestions on how to accumulate 1/4 in my picture? What would I do to show somebody in the picture the answer is 1/4? So where are the other 4 parts? Start circling groups of 3. Yeah, so there's a group of 3 here, another group of 3 there. And there's always more than one way to do it, but this is just one way to go about it. Okay, so there's 1, 2, 3, 4 equal groups. So yeah, it's also 1/4. Okay. Sometimes things reduce multiple times, and so that means we'll be able to find multiple ways to group stuff together. It just depends on how complicated the problem is. But we can always show it picture-wise and playing around. Just a note on the reduction, I didn't get to talk about this before. I've seen people write things down like 3/12. To reduce that, you would just divide by 3 and call it 1/4. Does anybody see a problem with that? Okay, so this is very dangerous. I'm gonna put a BAD on top of that. Reason being, and we'll review division in a minute, if you take 3/12 and divide by 3, we're going to develop a rule that says dividing with fractions means multiply by the reciprocal. So technically, this is really equal to 3/12 times 1/3, which is not 1/4. That would reduce down to 1/12. Okay, so if you're talking about reducing, writing notation like that is really bad. It's giving students 2 conflicting definitions on what it means to divide. So we do use division in reducing, but technically that's the way it happens. Numerator separate from denominator. Okay, so just be careful about that. All right, let's do another one. So you try drawing this and then I'll catch up with you. So take 3/4 and multiply by 2/5. Just like we did with the other 2, and see what you come up with. Oops, I drew that the wrong way, darn it. I wonder if it'll let me rotate it. Let's try. Oh, that's cool. Oops. So we should be able to show one version of the answer is 6/20. Now, one thing kids are going to notice after you do this a few times, the rectangle I highlighted in blue is the same rectangle described by the product of the numerators. It's 3/2 or 6. And so after seeing this area a few times, they're going to say, oh, the numerator of the product is always the multiplying the numerators before us. And they start to say, oh, well, we don't even need a common denominator because the new denominator is just the product of the old denominators, right? Because don't I have a 4/5 grid to work with? So then what some kids are going to do based on the previous examples is they're going to start looking for groups of 6 in here. And they'll say, oh, yeah, here's a group of 6 right there. And then 1, 2, 3, 4, 5, 6. Oh, I can't quite do it, groups of 6. Right, so that doesn't work. But aren't kids going to realize this reduces? So some kids are going to look at it and say, well, you know, the numerator and denominator are both even. So if they're both even, they would divide top and bottom by 2. Divide by 2. Divide by 2. So that should be 3/10. Can we get away with groups of 3 here? Oops. Or is it going to have to be groups of 2? What do you think? Abby? Groups of 2? Okay. So then we start looking for groups of 2. So 1, 2, there's 3 groups of 2 there. And then all together, I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so 3 out of the possible 10 groups of 2 are represented here. And there's lots of ways to organize those. That's just one way. So we should be able to show anytime we have a reduction, we should be able to regroup in the table. So this, like we talked about last week, leads to an algorithm. And the algorithm says if you have 2 fractions, a over b, and you won't use letters with the kids, c over d, then the answer is just the product of the numerators and denominators. So AC over BD. So for every kind of addition, subtraction, multiplication, and division, there's going to be ways to develop an algorithm by just using arrows to show what to do. Like we had the arrow algorithm for addition, arrow algorithm for subtraction. Does anybody remember the book's name for the arrow algorithm for addition and subtraction? No? We talked about the arrow algorithm for addition and subtraction last week, or last class, and last week. The book has it in there too, but they don't use arrows. I'll leave that as a mission for you for next class. What does the book call it for addition and subtraction? All right, let's take a look at those pattern blocks. So to use the pattern blocks, we got to make a key. So new page, and then we'll do division. And let's see, how does this work? Oops, there we go. We have that guy there. Oops, there we go. So that's what we're going to call a hole for this. And so then we have to identify what is the red piece. If that's a hole, what is the blue piece? If that's a hole, and what is the green piece? If that's a hole. And let's get rid of this stuff for now. So let's make our key, and then we'll start doing some multiplication with these things. Come on. So definitely make a note somewhere. If this is one hole right here, what would the red piece be? 1/4. How about the blue piece? Not an 1/8. You got the toys, whip them out if you're not sure. It would be a 6 because 6 of them fit in one hole. And the green then would have to be 1/12. Okay, so those are the kinds of things we're going to get to play with. What would 1/3 be with these figures? How would I represent a third? 2 blue ones together, because that would be the same as 2 6. Okay, so 2 blue. All right, so we're going to try some multiplication with these here. And so the first question I want to answer is, how about, let's see, let's try one of the ones I did earlier. How about 2/3 times 1/2? Oops, I wrote that too high. Oh well, 2/3 times 1/2. So here with these, it's a little harder to do the area because area is base times height, and these figures don't fit that description. So we're going to do groups of. So I want 2/3 groups of 1/2. Okay. So putting in more of an elaborate question, what is 2/3 of a group of 1/2 is the question we have to ask with these figures. Now, I want to know what is 2/3 of a group of a half. So that means order of operation wise, I got to identify what's a half first. Okay, well, wouldn't one yellow be a half? Okay, so given that yellow piece, we now have to say, okay, what is 2/3 of it? So I can say 1 yellow is 1/2. So now I need to know is what is 2/3 of a yellow? So playing with the yellows and the other pieces, what could you use to describe 2/3 of a yellow? 6 greens would be one way to talk about it. Yep. Okay, what else? Any other option? 4 greens? Okay, so we have a 6, we have a, oops, we have a 4. Which is it? That's true. Okay, so it's not 6 then, it's 4? Is there another way we could talk about it? 2 blues? Yeah, so I'm going to bring out my toys just to double check. So here's my hole up here. So this yellow right here is a half of it. If I grab a blue, that's 1/3 of that piece. If I grab another blue and rotate it, I now have 2/3 of that piece. So what I have right here is 2/3 of my 1/2. So I'm going to grab that into my notebook. and my pen. So this right here is 2/3 of 1/2. The final question is, what part of a whole is this now? So back here, we put it right there. So if this blue part right here is 2/3 of a half, what part of a whole have I illustrated in this picture? 2/6, excellent. How else could I refer to it? Yeah, we could also say it's 1/3 of the whole. Okay. Now, one thing when we're playing with this piece, this right here, we can do thirds, we can do quarters, we can do 6, we can do 12ths, but we're not going to be able to mess around with fifths because we have no piece that is a fifth of anything here. Okay, so there's only certain denominators we can play with these toys. Let's try one more of these and then we'll move on. Let's see if we can do, how about 1/3 of 1/4. So 1/3 times 1/4. So to do this, first I need to say, what is 1/4 of the whole? Once I get that, I can find 1/3 of that 1/4. And then I can identify what part of a whole that is. All right, so pattern blocks. So here's a whole. I need to find a quarter, and earlier we'd established that this piece right here is a quarter. So now I need to break that quarter into 3 pieces because I need to use thirds. What figure should I use to do that? The green triangle. So that green triangle right there is now 1/3 of my quarter. So let's grab that into the notebook and then make our final statement as to what part of the whole that's going to be. What part of the whole is that going to be? Anybody? 1/12 of the whole, yeah. Oops. All right, so this, looking at it this way, is half of activity or 3/4 of activity 8. We'll come back to that later. And then the other part, we can make pictures like this not just by cutting up something with pencil, we can fold paper and come up with the same answer. So we're going to do that with paper folding later. Let's take a look at division. What does division mean? What were our definitions for division? Think way back. Groups, not groups of, that was multiplication. Yeah, groups in, that was one. So for example, 12 divided by 3 means how many groups of 3 are in 12? Will that work with subtraction? So suppose I had something like 3/4 divided by 1/4. The question here would then be, how many groups of 1/4 are in 3/4? So this is different than multiplication in that I need to see the 3/4 and I need to see the 1/4 to make it happen. So if I'm going to draw that in terms of cakes, 3/4 divided by 1/4, I need to see what 3/4 looks like. And I need to see what 1/4 looks like. Oops. And so pretty clearly here, I can see there are 3 groups of 1/4 in 3/4. So the answer has got to be 3. Now here, the denominator worked out nice. So the question is, well, what if it doesn't? How do we go about it? Like, suppose we've tried to take 1/2 and divide by 1/3. So the question would be, how many groups of 1/3 are in 1/2? Now, just a note on the example with 12 before, when we look at groups in, that's that goes into symbol we use. 3 goes into 12 how many times? And so we can do that with fractions too. We could consider 1/4 goes into 3/4 how many times? So we're going to try and do that here with pictures. Next one. Here we go. So I'm going to consider 1/3 goes into 1/2 how many times? So to do that, I need a picture of a third and I need a picture of half for comparison. So let's see. A third with cakes is going to look like this. And a half looks like that. And shading. The way I've got it drawn right now, can I tell how many of one go into the other? The 1/3 smaller, right? So more than one of them fit in half. So I know the answer is more than one. Is the answer more or less than 2? Like if it's less than 2, yeah, so 2/3, if I add another third, that would be bigger than a half. So the answer is somewhere between 1 and 2. Okay, but they're not the same shape. When I was working with addition and subtraction, what did I do to compare them when they weren't the same shape and size? Think back, we did this yesterday. Cut them the same, yeah, they're cut the wrong way. So we have to cut each like the other. So I have to take the third and cut it in half. Oops, I wanted a pen, not a highlighter. Again. And we have to take the half and cut it in thirds. My claim now is that this piece right here is the same size as that piece right there. So I need to know how many groups of this fit over here. Well, how many pieces do I have on this side? I have 2. So here's one group of 2, right? So there's the one I was thinking about. How would I describe this extra piece right here compared to what I'm looking for? I'm looking for 2 pieces, I found 1. What do you call it if you find 1 out of 2 things you're looking for? A half, yeah. So what I see is for thirds, there are 1.5 thirds in 1/2. Here's 1/3, here's half of a third. Can we try that with the pattern blocks? Let's give it a try. So I am going to clear my screen. This time I'm going to take this as one unit right here. So we're going to use a single hexagon as one. And I want to know, let's see, how many thirds go into a half, right? This is 1/3, that's 1/2. And there's two ways to look at it. One way is to just take this and sit it on top. Well, there's one of them in there, plus a little more. Here's another way to think about it. I could break everything down into triangles, couldn't I? Oops. So the blue is 2 triangles, and the red is 3 triangles. Oops, turn, oop, no, not you, you turn, there we go. So I'm looking for how many groups of 2 live in a group of 3. And it turns out whenever you look at it like that, let me steal this into my clipboard. This is my division I'm doing right here, which you could say is how many times does 2 go into 3? Agreed? Okay. If 2 goes into 3, that means the other way to write this with division would be what? So here's a goes into symbol. How would I write this with a division symbol? It would be 3 divided by 2. 3 divided by 2. Or couldn't I write it this way, 3/2? Okay. And when you do it that way, this is what you have over here. And this is what you need. You need groups of 2. The answer is always what you have over what you need. That's the way division works. Is that a different answer than we came up with over here? Is 1.5 the same thing as 3/2? Or is it different? They're the same thing. Yes, 2 different ways to look at the same problem. Okay. So if we can break it into pieces, we can change fraction division into whole number division. And there's the answer. Okay. Here's another crazy way to look at it. This leads to kind of an algorithm to go about doing this. How many pieces did I end up with in the final answer? 6, right? A whole has 6 in it in the end in order to compare these two. So I don't think you'll see this in any textbooks, but I always thought it was fascinating. I have, let's see, what was it again? 1/2 divided by 1/3. 1/2 divided by 1/3. According to the way we rewrote them, a half is the same thing as 3/6, true? And a third is the same thing as 2/6. Once we have a common denominator, we don't need the denominator anymore. The answer is 3 divided by 2. Which is the way we developed it with the pictures. Either way, whether we talked about it with the pattern blocks or whether we talked about it with square cakes, it still works out that way. It's very rarely taught that with division you have to find a common denominator. But in order to sketch it out, you pretty much have to. There's really no other way to do it, because otherwise you're not comparing stuff. But it turns out fraction division is directly comparable to whole number division. Now, interesting things about this. The 2 here stayed where it was in the answer. The 3, on the other hand, got thrown up into the numerator. And so there is an arrow algorithm going on here, and it's kind of cute. 1/2 divided by 1/3. Since the 2 stayed put, we don't really have to worry about it very much. The 3 is the problem. It got moved up there. The other catch is that this numerator over here is going to get moved down. So there is an arrow algorithm for fraction division. It looks like that. Going from the right to the left, we take the second denominator, put it in the numerator, the second numerator, and put it in the denominator. Usual rule that people learn, does anybody remember the rule for fraction division? Oh, you do too. How do you divide without a calculator 1/2 by 1/3? Because you don't remember? The rule is, since we're flipping these, is to multiply by the reciprocal of the second number. We'll talk more about that after we do project 9. And so my answer with multiplication is pretty straightforward. It's 3/2. All right, let's do one more, and then I'm going to stop here and we'll jump into the activities. Let's suppose we had, we'll do 2 more actually, 1/2 divided by 3/4. So I want to know, how many times does 3/4 go into 1/2? Now, both of these fractions work well with the pattern blocks if you use 2 hexagons as a whole, or you could try and draw it with 2 cakes. So that's what I'd like you to try right now. Either draw this out with cakes or pull out the pattern blocks and try and solve it. I'm going to pause for a minute and let you try that and see what you come up with for a picture. And then we'll check the picture with the algorithm to see how it works. So I'm going to do it both ways. I think I'll do the pattern blocks first. Wow. Yep. Oh, are you first generation college if you're well, in terms of getting a college degree, you're first generation. I don't know. I would always go for it and then ask for forgiveness later if you're wrong. Okay, so then let's see, I've got 1/2 here. Oops, wrong color. So what do you think the answer is? What do you got? Okay, any other answers? Oops, wrong color. Got 1 1/3. So I'm looking for groups of that right there, right? So this is 3/4 of a whole. This is 1 1/2 over here compared to a whole. And so I'm looking for groups of 3 like that. So I had to recut this guy over here to make that happen. And so here I have 1, 2, 3. Here's a group of 3/4. And then if I grab these guys all together, there's another group of 3/4. So I think the answer is 2. There are 2 groups of 3/4 in 1 1/2. So again, I have to do a division is a comparison because I'm looking for groups of this in there. And they have to be the same size thing. I have 3 things there. If I break 1 1/2 into quarters, I have 1, 2, 3, 4, 5, 6 quarters. So this question can be boiled down to is how many groups of 3 are in 6? And the answer is there's 2 of them. I'm going to do it again with pattern blocks. Yes, you were wrong. It's a good guess, though. I'll come look at it. Hang on. Let me come look. But let me show you the pattern blocks. So I was going off of 2 yellows is a whole. So that means 3 reds is 3/4, right? So that's my 3/4. This is my 1 1/2. And so I'm looking for groups of that. So wouldn't you say right here is one of those groups? And then if I combine this one and that one, isn't that a second group of 3/4 there too? You know what you did wrong? Can I come look? Did you draw pictures?
No.
Ah, I said to draw pictures. You know what the problem is? You're multitasking. Stop multitasking. Okay, so we'll do it that way next. But I need you to be able to play with toys to come up with this, okay? This is actual math. Okay, so now we're going to take a look at the algorithm. The algorithm says if you're taking 1 1/2 divided by 3/4, you can use arrows to do it. Now, one problem I have here is the 1 1/2. In order to do fraction arithmetic, you really should work with mixed numbers. So what would 1 1/2 be as an improper fraction? No. Try again. Be 3. Yeah. Okay, so if you look back here, this right here is 1 1/2, and it has 1, 2, 3 halves that live in it. That's the other nice thing about the toys. They're concrete. You can hold them. You can touch them. You can feel the 3 of them. So I can say this is the same thing as 3 halves divided by 3/4. And the arrow algorithm says you start with the second fraction and reverse arrow. So 3 times 4 is going to give me 12. And 3 times 2 is going to give me 6. So my answer is whatever 12 divided by 6 is. 6 goes into 12 twice. Alternative algorithm is to multiply by the reciprocal. So 3 halves divided by 3/4 has to be the same as 3 halves times 4/3, which is 12/6. Super caution. You guys are used to taking something like 3 halves times 4/3. So caution. Is there anybody that would manipulate this before multiplying? So 3 goes into 3 once each, 2 goes into 4 twice. So the answer is 2 times 1 over 1 times 1. Why do I say caution here? Anybody know? No, you can still multiply across. That's okay, because that is what multiplication means. Just multiply numerators, multiply denominators. Why should we use caution with respect to the canceling I did here? Because multiplication is the only time you can ever do that. You can't do it in division, you can't do it in addition, you can't do it in subtraction. Multiplication is a special case. It's the only time you can pull that cross canceling. The reason you can do that is because you can multiply in any order you want, commutative property. So I could say this is the same as 4 times 3 in the top over 2 times 3 in the bottom. A number divided by itself is 1. 4 divided by 2 is 2. Right? So because multiplication is commutative, and sometimes a number divided by itself, well, number divided by itself is always 1, but sometimes we see that, then we can cancel. But it doesn't work in any other operation with fractions. So this cross canceling, you shouldn't teach that right away, and the books will not show it right away. They'll show it later after you've done a bunch. Otherwise, you run the risk of confusing that with working with addition and division, because you can't cross cancel with division. So for example, take 2/3 divided by 1/2. Would it be okay to cancel those 2's? We could try. If we canceled those 2's, then, well, what's left here? 1/3 divided by 1, which is 1/3. I'm just checking. Why can't I do it? Okay. All right. Well, let's do it the other way. What's the algorithm say about this? What's the proper way to do this according to the algorithm? We have 2 choices for algorithms. Tell me which one to do. Multiply by the reciprocal. Okay. So multiply by the reciprocal says this is 2/3 times 2 over 1. And nothing cancels here, so this must be 4/3. So which is the answer, 4/3 or 1/3? 4/3 is the correct answer, yeah. So we live in the age of massive technology. I could just ask Google what it thinks. Shall we try? Anybody got a smartphone on them? Oh, Corey, you got a smartphone right there. Do you have a web browser nearby? Let's go to a web browser. Oh, you got a computer there. Oh, yours isn't on, but let's try it. I'm gonna go to Google. Okay, how do I tell Google to do this? Let's see. I wanna take, what was it? I wanna take 2/3 and divide by 1/2. So could I just try typing 2/3/1/2? Or is Google going to be confused about that? Oh my gosh, Google says it's 1/3. What the hell? That's weird notation. What the heck does that mean? Interesting. Let me write that over here. Is this thing the same thing as 2/3/1/2? Is that the strange? Have you guys ever seen anything like that in math? Is there, so make like that one the bigger one? Yeah, you got to know which one's the main fraction bar. That's huge. Yeah, that dictates the order of operations. However, on a calculator, is there one division key that's bigger than the other? No, that doesn't exist, right? So how do we tell people what the right order to do thing is in math? Yes, Corey, you got it. Yeah, these guys have to be in parentheses in order to communicate to somebody in a string what we are doing in this very complicated thing right there. Okay, so that's the problem. Let's try it. Back to Google. Corey is totally on that order of operations. So I just need to sneak parentheses in here around the 2/3 and around the 1/2. And Google says the answer is 1 1/3. 1 1/3. Is that 4/3? How many thirds are in 1? 3 plus 1 is 4/3. Yeah, that's the same answer. Yeah. Okay, so Google agrees. The second way was correct. The only time you can cancel ahead of time is in multiplication because of the commutative property of multiplication, basically. All right, that's enough for now. I'm going to stop this recording and we're going to